concept that's rapidly reshaping how automotive companies develop, innovate, deliver quality designs, quality products, quality parts to the entire industry. This isn't just about new tools, but it's about fundamentally rethinking how we design our data landscape over and above. Okay? We're also going to be discussing about how data plays such a critical role in the entire engineering life cycle, right from product conceptualization, design, practical implementation into manufacturing, product delivery, and launch. So let's set the stage first to begin with. The automotive R&D landscape has never been more complex. What are we dealing with? We're dealing with traditional R&D issues. What are these traditional R&D issues all about? We're talking about exploding complexity, especially new challenges, new transformative technologies coming in, whether it's EVs, it is ADAS, it is connectivity, CCS, connected car systems, or even SDVs, which is our software-defined vehicles. There are also data silos that exist in our traditional companies, yeah? The ones that have existed for years and decades and centuries. We've had data silos working across the entire life cycle. Marketing doesn't talk to sales, sales doesn't talk to the other function on after sales. We don't have design talking to engineering, engineering talking to production, et cetera, right? So we have huge data silos, disconnected tools, disconnected applications, disconnected departments. There's slow iterations. That means we have manual handoffs, reworks happening between functions. We have fragmented decision making, right? We always wait for one function to finish one step before it moves to the other. Slow iterations, global collaboration hurdles, of course. Now, if design's happening in one part of the world, and you need to test in the other part of the world, possibly to comply with a particular regulation before it gets launched in that particular market, how do the two talk to each other? Can design, can test, share information, live market information, which is closed loop feedback, closed loop continuous improvement, right up front, back to design so that there can be corrections way ahead in the design journey or the product journey of the car or the vehicle being launched. Talent scarcity, of course, we have huge scarcity in talent. The ability to retain talent, understand what data is. Even the basic difference between data and information, not many people can differentiate that. Of course, now, in 2025 and of late, we have opportunities coming in, especially in AI ML, the ability to predict design changes, predict design failures that could happen. We've looked at a couple of examples that have been in welding and soldering at the very minute end item level. Will the two materials be able to adapt to each other, right? Can the shop floor be completely automated through a digital twin? Can we replicate what exactly will happen on ground in reality? Advanced simulations, agile development for faster life cycles, continuous integrations, of course, and ecosystem collaborations. Let's look at what exactly is Engineering Workbench 2.0, why it exists and what it really entails. It's actually a unified, intelligent, collaborative, digital environment for automotive R&D. What does that mean? It's driven fundamentally through data, end to end. One of the core principles that Engineering Workbench will rely on is centralized data. And I say centralized data, it need not be physically centralized. It can also be virtually centralized, and I'll come to that in the next few slides. Second important part is the source of truth. Now, the source of truth has a far more deeper meaning. It also involves tracking data lineage, how that data was generated, when it was generated, and how it gets utilized or consumed through the life cycle, through its data life cycle. And I'm not talking product life cycle. Now I'm talking about individual data lineage and the data life cycle. Key pillars supporting the engineering workbench are, of course, seamless integration. That means connecting tools, domains across functions, smart automation, being AI, ML driven. Now, AI, ML will work or will be as good as the data powering it. Okay? No matter how excellent your algorithm is, how your ML ops features work, if your data is inaccurate or altered or defined for a different domain or a different situation or a different level of complexity, your outcomes will differ for the same algorithm, okay? Real-time collaboration, this is exactly what I was talking of earlier. How we can use engineering 2.0 to collaborate across the globe, across markets, across design specs, across regulations and compliance needs for different markets, right? The same product that's launched in India might not be exactly the same that is launched for Africa or for the Middle East or for Europe or for Australia, right? There will be variances. Variances could be due to market conditions, road conditions, physical conditions, environmental conditions, regulations, no matter what, yeah? Enhanced traceability, extremely important. How do you trace? And this comes more from the concept of quality and error tracking and closed loop feedback for continuous improvement. How do I look at errors, feedbacks coming in from the market back into the design process and share it with my designer or the AI algorithm working with the designer to say, hey, you know what? This could be a potential area of failure. Now, coming to the power of centralized data, let's break down these silos, right? We're talking about disconnected repositories. Imagine the entire R&D process that has CAD, AE, PLM, all sort of test results, all sort of software codes, embedded into all these tools, all trying to work together, right? How do we bring these aspects, these different data sets, into a cohesive, streamlined storyline to your designer, which is the very first step, right? You're trying to conceptualize a new product, a new design for a particular market. You know that a particular market, from the, maybe from market research, you've identified what are the top 10 features that the market desires and wants to have, right? Do sunroofs work in a particular market or not? As fundamental as that, right? How do we bring all those aspects right up front to the design process so that you're creating a product or you're designing a product that really works for that market? Can I test a simulation or a virtual simulation of that final product through maybe surveys or whatever mechanisms that marketing uses to gather feedback from the market even before I go into production? Right? Which is one of the reasons why you see automotive companies really launching the future models of, it could be unrealistic to produce and launch right now, but you really see a lot of these companies, automotive companies, launching future models, futuristic designs, right? Including ADAS. We're now at ADAS maybe level 2 or 3 at the max in India, at the best, yeah? But reaching that level 5 and 7 is really far-fetched even as of today, okay? Now, what's the benefit of this? You're eliminating redundancy, ensuring consistency, consistent information flow through the entire R&D process, as well as reduce your errors, which is so important if your company especially is focused on quality. And if you have to get through regulations, especially with ADAS. There are new laws coming in, even on AI and on data, which mandate that companies that implement AI, and if that AI algorithm or that output impacts the safety of the customer or impacts critical decision-making by the customer, there has to be a level of transparency and validity or being provided to the regulation or to the customer when the customer or the regulation or the government asks for it. Okay? Moving next, accelerated development. This is one of the first critical impacts of having engineering 2.0 and a centralized data ecosystem. Now, when I say centralized, I'm not saying physical centralization. It could also be virtual centralization, and I'll come to that. What did we have earlier? We had serial processes, waterfall models, sequential ways of working, handing off tasks and data or sheets manually, Excel files. There was significant rework when you had to go back and forth, changes, feedback coming in from the market. Now, with engineering Workbench 2.0, you're looking at concurrent engineering happening. You get feedback for a launched model that provides input to your future product designs. Yeah? You're looking at automated workflow. Again, data powered with AI, ML algorithms on the engineering Workbench. You have rapid iteration, which means faster design to build and learn loops. So your designer is not constantly seeking marketing team feedback. Hey, did it work? What was the feedback? How many issues were reported in my customer service, et cetera, et cetera. None of that. Earlier problem detection, I mean, self-explanatory. So you see, we're not, your entire, what's the outcome of this? Your entire product life cycle, which would traditionally take around on an average 5 years, 3 to 5 years, is now shrunk, and you see a lot of Chinese OEMs doing this. Their life cycle is shrunk to anything less than 1 to 2 years, which is crazy, right? Traditionally been crazy. You don't see OEMs doing it that fast. Enhanced innovation and quality, new ideas coming in, data-driven insights, AI, ML, generative design and predictive analytics, huge, huge use cases in here, right? Not only from design and simulation testing in your digital twins, et cetera, but right up to manufacturing, going live with after sales and service support. Huge use cases on predictive analytics. Component failure, predicting component failure, even in the manufacturing side, even on the shop floor, huge use cases. Optimizing materials. Will the two materials that I'm potentially considering as a designer, are they compatible with each other? When I'm designing a particular engineering component, right? Can it be soldered? Can it be welded? Et cetera, et cetera. Easily traceability for compliance and root cause analysis, I've spoken about this, and also pinpointing the origin of quality issues much, much faster in the entire design feedback lifecycle process. I've spoken about continuous improvement already. The third impact, and possibly an important impact, according to me, especially when you're talking about global companies and global MNCs, automotive MNCs, is collaboration and global efficiency. Yeah, and this is extremely critical. A lot of companies spend a lot of money in driving or gathering market feedback, right? So how soon can that feedback be pulled back into your design team, which is centrally located possibly in one location? Real-time co-creation, maybe many teams working together across design and test at the same time. Simplified handoffs. Who owns the data on design? Was it signed, verified, and then communicated? Supplier and partner integrations. Maybe their parts and components, test results from one supplier, possibly delivered to another. And how does that coherate or come together back to the design team that's creating that prototype before launch? And of course, having a unified digital thread. Now, the key considerations while building your engineering workbench, right? The first one is your data strategy. And to the data strategy, I would like to add one aspect of data centralization versus virtualization. whilst you give your business owners the impression that data is centralized and accessible from a common location, could be your data catalog or your data marketplace, your data could actually not be centralized, physically centralized in one data warehouse or one data lakehouse or whatever that might be, okay? It could be located across different databases, across the globe, across specialty applications, tools, and databases, yeah? That's important. Also, the kind of data products your data scientists or data engineers develop, how they leveraged across what use cases, that's critical to know. So defining your data strategy upfront, who owns the data, how is that data being created, how is data lineage being tracked, how is it being governed, data quality, accessibility, availability being governed, that's critical to the entire process. I believe particularly in starting small with MVP products, okay? And ROI on any task and activity is a must. Technology in itself has no value unless it brings business or monetary benefit. Yeah, some of us as technologists feel a lot of pride and a lot of pride basically in just delivering a technology. But as a digital transformation expert, I take a halt there and I say, hey, so what? I could get a consultant, I could just get anyone else in the industry, outsource it to anyone and get it done. How is that piece of technology monetized by a company, adopted by a company? That's critical, and that includes data in scope, okay? So how you're monetizing data, what kind of business use cases one can create is critical. Of course, with data and AI, we're talking about a cultural shift, not only at the fundamental doer or the worker level, but also at an executive level. How are you using these tools as decision support systems, at least for now? I don't know what the future will look like. Or how are you using AI to augment or increase the productivity of an individual person or a group of people or your team as a whole? The technology stack, what kind of technology stack? Do you have cloud-native platforms, APIs? What kind of security, data security measures around the engineering workbench you put in together? And of course, the talent and skills goes without saying. Sorry. Am I going in the wrong way? Yeah. Okay. So what's the future? And what does it hold for all of us? Hyper-personalized vehicles. That means if they know Jasmine does not drive her vehicle well. The car knows Jasmine does not drive her vehicle well. Every time there's a left turn, she takes it very steep. The car can sense it for herself, right? And say, hey, my ADAS system will automatically maneuver or press the brakes at the right time when I try to purposely take a sharp right or a sharp left. Okay? So that personalized, hyper-personalized vehicles. It could not only be with driving, it could also be that, hey, every time I enter my car, I like to hear Apple Music chill, right? It possibly sets me in the right mood so that I can drive my car peacefully, even though I've come out of a harsh meeting or whatever that might be. Or if I'm sitting with my daughter, the car senses it and says, hey, where do you want to go with your daughter today? You know? That level of hyper-personalization. Continuous engineering, as I mentioned before, constant updates and improvements, even post-sale of your car. On-the-air updates, connected car services, right? If your car broke down somewhere in the middle of the road, anywhere, and let's say in the most remotest areas of India, can you get on-road assist? Can your car tell the nearest service center or your potential service center relationship manager or whatever that, hey, you know what, Jasmine's car's broken down. Can you come there and fix it for her at whatever be the price and all? At that point of time, you really need help, right? Closed-loop product development, meaning learning from your actual field data from the market post-launch, And of course, emergence of the so-called AI engineer. And I believe this for sure because your human AI collaborative design is the future. It's already happening. It's not new. And sustainable development. Through digital twins, through simulations, can I optimize the use of resources? Can I reduce the number of cars I deploy for crash test before going for a formal launch? And getting, of course, the regulatory approvals and so forth. And hence, reducing the life cycle impact and the total time for developing a new product. All right, that's it from me. Thank you for listening patiently. You've been a great audience. And I'm accessible or available for discussion after this conversation and also on LinkedIn. Thank you.